Let me just say a little bit more about this introduction to imaginary and complex numbers. So I introduced this number I, whose square is -1. Turns out geometrically where you put that is on this vertical axis, in this metaphor of the road and getting out of this prison of this one-dimensional road that we had to live on. I lives right here, and -I, turns out, lives right here. This is not in the book. They leave this, or at least not in this section of the book. They leave it for later, but I want to talk about it right now. It turns out that there's very good reasons for putting these all the numbers we're going to discuss in a plane, and it turns out that the imaginary numbers live perpendicular to the real number line. Now that doesn't tell you immediately how you should think of them. It really takes a while to get used to them enough to have a good way to think about them, and we're just going to kind of use them on a very manipulative level mostly to start out with. But if you want to have a picture of where they live here. So there's 2i as well. I could multiply that by 2. I could multiply -I by 2. I could have like 1.5i or I over 2. I have a whole real line worth of imaginary numbers. And as soon as you introduce I, you can multiply that by any real number. And so these guys are called the pure imaginary numbers. And the pure is because we're going to start mixing real and imaginary, and that's going to break us out into the whole plane pretty soon. So let me just talk about the manipulation here. So the square root of -1. Another way to say that I squared is equal to -1 is that the square root of -1 is by definition I. Every time we encountered that before, we said, that just doesn't exist, we can't talk about it. And now we're saying, no, we're going to give a name to it, and more important, we're going to have algebra associated with it. And even more important than that, the algebra is going to mean something and be useful for us, but that takes a long time, okay? So the square root of -1 is called I. And then, like the square root of -25, well, we could factor out the squares just like we usually do. That's 5 square root -1. So that's going to be 5i. So now that means that we have the square root of any negative number now. Here, that 25 happened to be a perfect square, so this was an integer. A little more complicated would be like 49 over 4. You can take a 49, which is 7 squared out, and 4 is 2 squared. So that works. And we can even just do ordinary algebra with that. Notice these are all coming out as plus i's, not minus i's. That is a convention. It is absolutely just a convention that when we put the square root symbol, it's like our convention that square root of 2, or like square root of 4, was not -2. Similarly, the square root of a negative number, we're going to, by convention, use I and not -I, even though -I squares to -1 just as I does. And it turns out there's some really tricky stuff. I'll talk about in a sec about that. Actually, maybe we'll talk about that in a different video. So here's another thing we could do. We could do like -12 square root of -7 over 36, say. Okay, so I don't take out that -1. I leave that in there so that I know the I is going to come in. So I get -12. Now, the 36 is a perfect square, so I can take that out. The root 7 I take out, and then the root -1 I leave. And I get -2 root 7i. That's about as complicated as we're going to get for now. Let me go ahead and mention this annoying thing. What we've done here is we've used this rule that the square root of a product is the product of the square roots, but it's actually very dangerous to do that once you get into negatives. You can do it when you're factoring out a positive, but let's do a little calculation. If you do the square root of -4 times square root of -9, if you do them individually, that's 2i times 3i. Okay, and if this still feels weird and very artificial, it's supposed to. This is the level we're at right now of understanding with these things. It's a very artificial thing, and hopefully we'll get some more familiarity with it. Eventually, I hope to convince you, well, I don't know. Eventually, if you go on to mathematics, certainly, you start to see that this is the real world. Everything, including imaginary and real, and the mixtures we're going to introduce soon. That's the honest-to-God real world, and calling this the real number line is really a misnomer. But right now, it should feel pretty formal. So let's finish this computation. That's 6 times I squared. Hey, that's -6. Okay, but let's see. here's what this is not equal to. And it's really unfortunate. I just apologize. There's deep reasons why this happens. It's not just some cruel trick on the part of mathematicians. It turns out that is not equal to the square root of 36. You can't just multiply the minus 4 and minus 9. You can't combine it as we're used to doing when everything is positive, because that would be 6 and not minus 6. What's going on here is there's this convention that square roots always go to I and not minus I is just causing problems. And unfortunately, we have to have a convention like that, or else we're never going to get a sensible answer. So, unfortunately, the square root of AB is no longer equal to the square root of B if both AB are negative. You just can't do it that way. And we'll talk about how to avoid that and be real careful about that. Your homework is really just based on this level so far. And that's a good place to stop for this one.